So we have 4 different unit tests. 2 of the unit tests depend on performing a filter operation, leveraging the contains extension method that LINQ provides. The other 2 unit tests actually depend on the intersect method instead of the contains method to again accomplish the filtering of data. So we see what the difference is in regards to the amount of time that it takes to execute the filtering. So when we take a small set of data and we apply the contains method to a large set of data, we see that it could take up to 5 seconds. Well, that 5 seconds is dependent on a small amount of data having 1,000 elements and a large amount of data having 10,000 elements. And this is the same setup that's applied for each of the methods. For our methods that depend on the contains method extension that LINQ provides to filter data, and also the same setup for the unit tests that depend on the intersect method extension that LINQ provides. However, we get clearly different results in regards to the behavior of the contains method versus the behavior of the intersect method. So when we attempt to run this test right here, this small set contains large set, to accomplish retrieving filtered data, we can go ahead and run this. Last time we had 5 seconds. It's turning right now. It's turning. 6 seconds. Okay. So what exactly occurred when we executed this test? Well, first, we built a data set of 1,000 elements that we call our small set. And then we build another data set of 10,000 elements that we call or designate as our large set. In regards to the implementation details of how we construct these elements, we rely on a factory. Specifically, we call this a part factory. We're building parts. And so this factory, which is a part factory, has a method called build for. So we say part factory.build for. We assign a name of the set that we're going to be constructing the elements for, or the parts for. And then we pass in the amount of parts that we want to build. And we call this our order amount. So in this case, we say small set equals part factory.build for. The name will be small set, and the order amount is going to be 1,000. When we dig into the implementation of what this factory is actually doing, this factory is producing parts, and then it's basically creating, in this case, some container, assigning the name of the container, and also assigning the parts to this container. Now, where the actual magic happens in regards to this implementation is its produce method. This produce method is actually taking in the order amount for the parts that it needs to produce, or the number of parts that should be created. And for each part, it's going to assign a stock code property, in which the stock code is going to serve as a unique ID for each part that gets created, in which the stock code is going to start at stock_0, which is going to represent or reflect the current index in our for loop. And it's going to go all the way to, obviously, the nth number. In this case, we're creating a small set and a large set. Our small set, again, is 1,000 parts. So we're going to have our very first part is going to have a stock code of stock underscore 0, because that's the very first index that we're going to use. And then the stock code for our last part that gets created based on the order amount of 1000 that represents our small data set is going to be a stock code that's going to say stock underscore 999. Okay? So that's the way our factory works for building our data set. When we go back, as a continued part of our setup, we have the construction of our queries. Now, this isn't necessarily generating the data, but more you could think of it as qualifying how we're going to generate the data. So, with that said, we're going to first generate a query that's going to represent our small set. And we say this by saying the parts in our small set, we're going to go ahead and select the stock code. So our small set is going to basically be 1000 stock codes, as we identified earlier in our setup. So we have 1000 stock codes that are going to be represented in our query when the query gets executed. We then prepare our next query. Our next query, we're going to say, is going to be represented by the parts that are in our large data set, where for each part in our large data set, it needs to be contained within the executed query of our small set query, which means that we have 1000 parts that is going to be in our small set when this small set query gets executed. And so for each part in our large set in which we're keying off the stock code, when this small set query gets executed, we're going to basically assign that part as a result of what it means to be filtered data, or that part is going to be the result of a part that is shared between our small data set and our large data set. Again, we haven't really created any other objects except for our part factory building objects. All we have done is created queries, which is pretty much we're just like the SQL language. We're preparing a query for how we're going to qualify the data that we're going to get, but we're not really executing it, which means that these lines, when they get executed, is going to be very, very, very fast because we're not doing anything. Now, these lines get executed when we finally enumerate the result of our query. So specifically, when we enumerate the result of our query expression is when the operation finally gets executed. And that happens within our test and verification section of our unit test, where when we invoke the count method that LINQ provides, it's going to execute this query that depends on this query, or should I say is qualified by this query, and it's going to build that list, in this case of 1000 parts that are really 1000 stock codes. And we're verifying that our contains query is going to generate a list of 1,000 elements, and that the count of those elements that are the result of this query being executed should equal the same amount that we designated in our small order, which is 1,000. Or should I say, when this query gets executed, we realize that the parts that get created in our small set that this part factory builds are going to be the same parts, even though they're different objects. They're going to have the same stock codes. So pretty much the same parts that get generated in our large data set, except our large data set is going to have 9,000 more parts, but they're going to share the first 1,000 parts. So when this block of code gets executed, it's very, very fast, because all we're doing is building our queries or our query expressions, but we're not executing it yet. And that's when we finally get our execution. And again, when we run this test, this is the slowest test, right? When we're taking a small set and we're basically filtering data by using a small set and figuring out if it contains elements within a large set. So this time it took 7 seconds. Now, we see that in our unit test explorer, or our test explorer, that was pretty slow. That's the way it's organized by performance. We then go to our large set contains small set test. And in here, we have the same setup, right? We have a small data set that's composed of 1,000 elements. We have a large data set that's composed of 10,000 elements. We construct our query to represent our large data set. All right, and we say, large data set dot parts dot select on the key of, for each part we want to retrieve the stock code of that part. So when this large data set gets executed, we're going to have 1,000 stock codes that we're going to use to run a compare on. So that's our large set query. Next, we do our contains query. And our contains query is basically going to be for each part that's in our small data set, which is 1,000 parts. We want to know if that part is contained within our large data set of 10,000 parts, or really 10,000 stock codes, which a stock code serves as an ID or a part ID for a part. So in here, we're leveraging the contains operation, but we're using that from a large data set and we're applying it to a small data set. So for each part that's within our small part list, see if that part is contained within our larger data set of parts. And the execution of this is very, very fast because, again, we're just building our query. We're not executing it yet. The execution of our query, in which our query stems from IEnumerable or IQueryable, doesn't really get executed until we leverage or invoke a method extension such as count or toList, or there's some other methods as well that are in the enumerable type. And this is our test and verification. So when we run this test, we see that it took 433 milliseconds 433 milliseconds is a lot faster than 7 seconds that it took a similar test in which we pretty much swapped how we were going to apply the filter. One, we did a small data set and checked if it contained, if the elements within the small data set were in the large data set. In this case, we're taking the large data set and seeing if the elements in the large data set are in the small data set. So, next we go to the intersect methods that LINQ provides. Now, when we execute this test over here, this intersect large set to small set, go ahead and run it. We see that it takes 15 milliseconds. 15 milliseconds is a lot faster compared to 433 milliseconds, which was at the time our fastest. And 15 milliseconds is a heck of a lot faster than the 7 seconds that it took with our worst performing unit test to filter data. When we look at the implementation details of this unit test, in which we're doing an intersect of a large set to a small set, again, we have the same setup, right? 1,000 parts in our small data set, 10,000 parts in a large data set. In order to implement the intersect, or in order to execute the intersect method extension that LINQ provides, we need to implement the interface I-equality comparer. In this case, we have something called category part equality comparer. We can look at the implementation details in here, and it's pretty self-explanatory. We need to implement a method for equals. What does it mean when you compare one part to another part? How do you figure out if those parts are equal to each other? In this case, we're basing it off of the stock code. The stock code is a string, and so we also have to implement get hash code, in which we just leverage the built-in functionality that .NET provides for getting the hash code of a string. So we just say, stock code, which is of data type string, get hash code. And that gives us, for the most part, a unique string. The specification for get hash code in regards to how it's applied to strings doesn't necessarily guarantee that your string is going to be unique across different applications. But in this case, it's pretty safe. So, just like the other two unit tests that I went over, in our setup, we also are building a query. This time we say, for our large set of data, which contains 10,000 items, intersect these 10,000 items worth of data with a smaller set of data that has 1,000 items. And we're going to identify if these items between the two sets are shared based on the category part comparer that we've implemented. Now, with this said, again, this query is nothing but a query. It has not been executed yet. It doesn't get executed until we implement, or we call this count method extension that LINQ provides off of the query, and that's when the results of that query gets enumerated. And we basically, again, do a assert, or should I say verification, that the first 1,000 parts that are in our small data set, or should I say all the parts that are in our small data set are also the same parts that are contained in our large data set. And that's what this is doing. And so when we run this, let's see what we get. We get 22 milliseconds. Run it again. 16 milliseconds. Run it again. 19 milliseconds. So maybe we have an average of 19 milliseconds when we run this unit test, in which we're doing an intersect based on a large set of data intersecting a smaller set of data. The fastest result is when you take a smaller set of data and you intersect it with a larger set of data, which we see right here. So right now it says 20 milliseconds. If we run it again, 26 milliseconds, 14 milliseconds. It's kind of inconsistent. If we keep on running it, 13 milliseconds, 16, keep running it, 15. Just to make sure that on average it's consistent, 28 milliseconds for the other one, 14 milliseconds for the other one, 12 milliseconds, 17. Go back to our intersect of a small set to a large one, 17, 19, 20, 19. So they're very, very close, but it seems as if the large data set intersecting with a smaller data set, it looks like it's the fastest, but barely. So that's it. That's a demonstration of the performance that I've measured when using the contains extension method that LINQ provides versus using the distinct extension method that LINQ provides. Now, why is this occurring? Well, the contains extension method that's provided by the LINQ library is not responsible for generating a list of data. What is responsible is for identifying if a condition within a data set regarding each item or element within that data set is true or false, and that's it. The contains extension method is not responsible for generating a set of data. However, your intersect method is responsible for generating a set of data if that data is common between two different data sets. So earlier, I was attempting in my past work to basically get filtered data by saying, my data set dot select dot or my data set dot select, and then within parentheses, I would basically say if the items within my data set is contained by another data set. And it just took a lot longer because it's doing more operations than is necessary. And again, this is why I put emphasis on the intersect method that's provided, because that's what the intersect method is built for. It goes ahead, well, the implementation details is with the intersect method, it will run a distinct operation on each, on a data set to identify unique items within that data set. And that's how it does its compare. So it doesn't do any more than what it's required to do. So that's pretty much it. If you like the video, if you have feedback, if there's something that wasn't necessarily clear or that I was just wrong on, by all means, please inform me. I appreciate the feedback. My name is Scott Nimrod, and that's it. Take care.